both the things, and I'm going to pull this by force F. This is a string. Let this be radius r. Mass of this be 2m. So let this be solid sphere. Let this be disk. String is wound on both the rigid bodies. Surface is rough. Friction sufficient for pure rolling. No. What I do, I'll take a string, I'll wound on it. Then that particular string, what happens, it's made wound on this one. Then they're kept on the surface. I'll pull this one. So now I'm asking what is the acceleration of both the solid sphere and the center of mass of the disk, that one. So let me call this is C1. Center of mass, this will be C2. Okay, work out. A string is wound on both the rigid bodies and kept. A string is wound on both the rigid bodies and that are lying on rough horizontal surface. Find the acceleration of rigid bodies. Like connecting, no? We did earlier only one. So I'm just taking this one here. So let's do one thing. What can happen here now? Any forces, how do the forces will act here? How to determine the condition? No, how to get the direction of friction? So can I assume it in any direction? No. You have to be careful. Huh? What earlier, that story is applicable only for in limited case. Only if a force F acts on a rigid body, that's all. Okay, what I should do is like, where I applied a force F at the center of mass, C1, then the string will become taut. So let the tension T. Here the string will become taut, it will be tension. I know it's a disk. I'm very sure where the friction will act for this and where the threshold point for the disk will come here. So will you remember R by 2? And if you apply force above the threshold point, how the friction should act forward. So there's no problem with this F2. Here I'm not very sure. Then it must have a pure rolling. Who will accelerate center of mass? F will be greater than T. Go back to the basics. The applied force will be greater than tension. Then no slipping occurs. Friction is sufficient for pure rolling. Condition is given. So what is the acceleration of this point? P1 must be 0 along x-axis. And the center of mass, in fact, in what direction will accelerate? Will accelerate towards right. A1, it will accelerate towards right. So therefore, alpha 1 must be like this. Then the friction must act like this here. I think you should not assume random way. Are you able to understand? I'm trying to tell that one. Say, who will produce torque, net torque, clockwise torque? Due to friction only it can come now, because tension will produce an anti-torque, counterclockwise torque. Only the friction can produce clockwise torque. So therefore, the friction must act towards left here. I just picked up this problem so the students has to really analyze here. Acceleration of center of mass, this will have alpha 2. Okay, let's write the equation. Rather than solving, let's learn how to get all the things. First, what are all the forces that will be acting here? Translative motion will describe F minus T minus F1 equal to 2m into A1. Then rotative motion, F into R minus T into R. It is a solid sphere, 2 by 5 mr square alpha 1. Condition for pure rolling, acceleration of point P1 along x-axis must be 0. So A1 equal to R alpha 1. Leave it here. This is next come for this one. T plus translative motion of the disk. T plus m into E2. 2 by 5, 2m, no? Oh. Mass of the solid sphere is 2m. No. T plus F2 equal to me2. Then what about the torque? T into R minus F2 into R is equal to m r square by 2 into alpha 2. Condition for no slipping, AP2 x must be 0. So therefore A2 it should be equal to R alpha 2. No. How many unknowns are there? F1, F2. Sir, I'll write F1 equal to mu M1G, F2 equal to mu M2G. No, it's a rolling friction, not a sliding friction. So what to do now? So many unknowns are there. No? I need one more equation. I'll go for constraint. What is the string? Acceleration of this point should be equal to acceleration of this point because string is horizontal here. String is inextensible. What is the acceleration of highest point? So P1, P2, we took it. So let me take some B1, B2. Acceleration of point B1 should be equal to B2. Any reason? String is inextensible. What is the acceleration of point B1? This is B2. What is the acceleration of point B1? A1 plus R alpha 1. What is the acceleration of point B2? A2 plus R alpha 2. Solve it. So solve for all that one. You'll get first expression for tension. Then you can work out all. I think the biggest problem is what? Sir, how to get the direction of friction? Condition for pure rolling is what you have to keep in mind. Then you have to predict here. With that only you are supposed to predict. I'll scroll down. There is no limiter. I can just bring any of the conditions. So you must, student must what happen? Have the basics, how to apply things properly. And now let's go for block upon a block condition.